Assalamualaikum and very good day to everyone. So I am Fitri Yaakob from MJIIT. So basically this project or this product is based on for the designing early warning flood detection and monitoring system via IoT. For customer and need identification, floods contribute to significant danger in life and property damage in many areas over the world. I've shared two photos here, left and right side on the top. So both is taken in big city. Left side is taken 2020 September in Lebo Ampang, Kuala Lumpur area, and the right side taken in 2020 June in a Stadium Shah Alam. At the bottom, this is a video I share. On the left side is taken November 17, 2020 inside the Kuala Lumpur, UTM Kuala Lumpur. Right side, this is close to Mindef, taken on the same day, November 17, 2020. So this one can show us that the flood damage have caused up to an average 100 million annually based on the Malaysia Flood Management 2015. And from there also at least 876 deaths since 2006 based on the Malaysian Flood Management. For the customer value, this product can be used for the private sector, such as a shopping mall, industry, and also mainly for the fire and rescue team. For example, like J pump, fire engine. This product also can be used for the city council and for also for the individual use. For the customer value proposition, the rescue team basically can save time to place the flood victim at a safer place. Even for the rescue team, for example, they can get the accurate data about the water level and also the water pressure to know the current situation. The owner of the private building or event can handle their belongings, means they can put them at the safer places before the flood damage their property. In terms of sense of customer urgency, we know that this product can improve the traditional way of monitoring and detection by fast time of tracking and detection the current situation and also in line with the trend for the IR 4.0. For product description, so this is our integration of IoT system based on this block diagram. You can see that we have our main controller and we have our input and output. So our input basically is, for example, like we have our GPS to indicate the location of the place, and then we have our water level sensor. We also will have our water pressure sensor. For our output, this IoT can link with the platform internet. Then we have our solar net valve. On the right hand side is for our coding system. As I mentioned just now, so this is our core non-MCU as our controller. So we have our input and our output. So our output here is basically, for example, like water pumps, solenoid. We also have a relay and power adapter. As an input to the system, for example, we have here GPS to locate our location, our waterproof sensor to detect the level, and also for our water pressure sensor. So this is an example table that will indicate the level of height, safe level, warning level, and critical level. And this height is depend on the specific scenario. This is our product, our prototype. So this is overall circuit setup. So we have managed to enter the national competition basically. So we have did our pilot study in UTM Kuala Lumpur. So we put our measurement in this drainage. This drainage is at end of the, you can see the yellow here in our KL international campus map. So we did the measurement for 7 days, 24 hours. The idea is to collect the raw data for the scenario and then we monitor through the GPS. Okay, this is the results based on our testing. So we have three different level just now. So we have our safe level A and we have our warning level B, and then last one is the critical level. So from here we can see exactly this is the raw data, the real time data that we have collected based on the 7 days, 24 hours. So this one indicate that the water level is lower than 14 cm. For the warning levels, it indicate between 14 to 18 cm, and then for the critical level, the water level above than 18 cm. So from this raw data that we are collected, so we can give this information to the rescue team, for example, plus the location of the area. So for our product, must be easy and faster installation to process. Second, we are required a few modification and additional part to install. The most important here is we need required a Wi-Fi server, since this is IoT approach. And last but not least, users are alerted and precautions step can be taken ahead of time before the flooding become more worse. Let's see for the market competition. So if for the market competition, so far based on our finding, we cannot find any product that available yet in Malaysia market. Most of the market that already existing product is mostly in US, Japan, America, Canada, and others. You can see the power for the system is based on the solar, and you can see how they're used for different purposes for the flood detection. So our market approach, we have innovative functioning and reasonable price. We have a targeted customer. So far, Alhamdulillah, we have a good advisor or collaborator from JPAM, and currently we have a new Sendirian Berhad company that interested on this product. In technology plan, we have early preparation, can save life, economic value, and what is the SDG align. So if you see here, the SDG align is we are focused on SDG number 13, allows early detection so that the residents are alerted ahead of time. And then for the safety and commercial value. So I'm not good in the business model, but we believe this one can be used for the private sector, shopping mall industry, fire and rescue team, city council, and might be individual purposes. So the product cost is only 3,000, then we can might be sell it in the 5,000. If you compare with the available one from the outside international price, they are more expensive. Before I finish my presentation, I would like to share with you some demonstration product about the flood detection and monitoring system. With that, I conclude the presentation. Thank you.